Another place that we can use algebra is when we're deciding how much to invest in which account. We have to do our homework ahead of time. So first off, we have to answer the question, how much do we have to invest? And in this case, we have $500,000 from an IRA at the time of retirement. And I hope that you also have a nest egg at the time of retirement. That seems like a crazy amount of money right now. We've also done our research and we found two accounts that we're comfortable with. One pays 5.2% and the other one 7.7%. We talked about before that with the greater return there's greater risks, so we don't want to put all of it in the 7.7%. We've also figured out our goal, and so our goal was to have an interest earning of $34,000 from these two accounts and this investment. So in general, what's happening is we're putting money, I'm going to draw boxes. So we're putting money in this box, and we have two accounts, so we're putting money in this box. Both of those boxes are going to earn us some interest, and we want to end up with, wow, struggling with my pen. Let me try again. We are going to end up with $34,000 as our goal. Now we know a little bit about the accounts. We know the one account pays 5.2%. We know the other account pays 7.7%. And what we have to figure out is how much to put in the accounts. So since we don't know it, I'm going to use a variable to represent an amount in this account. I don't want to use X in the other account because by using the same variable, I'd be saying I'm splitting my money 50-50. And that probably isn't going to come out to be $34,000. I really haven't made the decision to split my money 50-50. What I do know is that I have a total amount of $500,000. So I'm going to write that in here. And I'm not putting it all in here, so I'm going to subtract out from that $500,000 the amount that went into the first account. At this point, I'm ready to make my equation, so I need to change my percents to decimals. So 0.052, moving my decimal place 2 places, X. And then I'm going to add from the other account 0.077. I need to use parentheses here because I have an expression. I have the 500,000 minus the amount that went in the other account, and my goal from both of those investments is to earn $34,000. So my first step is to do the distributive property, and I need to distribute this to both pieces. From that I get 0.052x plus, I'm going to type this into my calculator, so 38,500 minus 0.077x is equal to 34,000. Next, I can combine like terms. I have an x term here and again here. So again, I'm going to use my calculator. So 0.52 minus 0.077 gives me negative 0.025x plus 38,500 equal to 34,000. Now I can subtract the 38,500 from both sides. So on the left-hand side, I'm just left with my x term, negative 0.025x. And on the right-hand side, and this works out very well, I get a negative as well, and I know two negatives will make a positive, so that seems like a good thing. And I get 4,500. So final step of solving the equation, I divide by the negative 0.025 on both sides. This side this cancel, and I have x equals, and again I'm going to use my calculator here, type this all in. Two negatives do give me a positive value of 180,000. So now I need to take this number and make sense of it. Up at my original setup, the x was the amount invested at 5.2%. So right now I know that in this account I want to put $180,000. And then I need to figure out how much to put into the other account. So I have this expression that tells me how to figure it out. I'm going to take the total investment of $500,000, subtract out what goes in the first account, so $180,000, and that will give me the investment for this account at $320,000. So as you can see in this example, once we make the initial decisions about how much to invest and what our goal is, once we find accounts that we're comfortable with, we can then use some algebra to see how to distribute that money between the different accounts.